Welcome back everybody to the next stage in our CNC process. So let's start. Hopefully you will have realized that the first thing we need to do with our vehicle is to a drilling cycle to remove and make sure we accurately drill out the axle holes for our vehicle. So to do this we're going to select the drilling option. We then for the first time here have to make sure we specify the cutter. I already have, so it appears in my open documents, but if you go plus by type it will be saved down the bottom of the ball mill folder like it should be. Having done that, I'm going to select a few things. Now, if you haven't already, the whole faces need to be selected. That's rather obvious, hopefully. Only those two. I didn't mean to select that edge there, but it doesn't make too much of a difference. Having done that, I'm going to make sure that we do the different heights. So these are to do with the clearance heights of our vehicle. Now, clearance heights are quite critical because it's how high the machine will move before it will do the next operation. Now, we want these to be reasonably high, but 47.5 unfortunately is a tad tall. We actually only want that to be about 45. If it goes much above 40, well, let's go 43. So that's going to be an offset of 43 there. So let's go, what, 6.5? 44? That'll do. If it's any higher than about 45, the machine actually can't lift up that high. It has a limit how far it can go down. Okay, the bottom height for the material is also really critical because that's how far it will go down. As you should know, if that was the stock top, it would only just touch the top of the material. We're going to go to the origin, so it's halfway, and we're going to go -4, so it goes slightly further. And then we're going to select OK. And what we can do now is have a look at the simulation tools. So the simulation tool allows us to visualize what we've done. So I select simulate, I go tail, stock goes on. Once it's loaded, I can then click play. Drills once, drills twice, job done. Perfect. Okay, let's desimulate. Go back to selecting code, so maybe I'll just click close instead. I'm going to do a quick single code basically to remove all of the stock material as fast as possible. It's a parallel code. Okay. And I'm basically going to specify exactly what we've already done, except for the fact that I want a boundary box for the machining boundary, which is where that original sketch comes in, like so. Tool center in boundary is fine, though I'm going to put an additional offset of 2 millimeters on it. We'll have a look, we'll have to check, because what we want to do is make sure it doesn't clash with the spigot. I'm going to then select the model surfaces. Sorry, I'm not going to do that, I'm going to leave it. And then I'm going to go to clearance heights and again make that change of 6.5. Oops, not 63.5. And again the model offset needs to be the origin -4. Okay, having done that, I'm going to click OK. And I'm just going to show you what the parallel code looks like. Once it's been generated up in the top left here, you've got a percentage range of how long it's taken to do that. You'll then be able to visualize what it looks like. So to start with, it might be quite rough. The gaps are going to be rather large, and the direction it goes in is going to be wrong. So if we simulate that code, we can very quickly see how it works. It moves the tool over the material. If we speed this up so it's really fast, you'll notice that it leaves some horrid ridges, what we call curve, between the cuts of the cutter. So basically what we need to do is modify our settings so that they are not so pronounced, and that's basically by reducing the distance between each pass, so it's a lot narrower. Okay, I'm going to close that now. I'm going to zoom out a bit, go to parallel pass, double click on it. I'm going to go to the passes selection here, and I'm going to go step over of 0.7. 0.6. The reason I use that is because it's 10% of the diameter of our drill bit, which means that it'll have a very small radius on it. Both ways, direction is fine. I'm then going to be trying not to laugh at the pop-ups that appear because of people seeing these videos as I upload them concurrently while I'm recording them at the same time. I'm going to then also just make sure that the degree pass direction isn't changed to 90, oops, not 1690, so that it goes across the vehicle rather than along the vehicle. Selecting OK, we'll just wait for the code to be regenerated. Hopefully it won't take too long. And then we will simulate this and check that that looks okay. And it does sometimes take a little while to generate the code. It excessively long on this vehicle because I am recording at the same time. Okay, you can see immediately that there is a much, oops, I believe the lights have just turned off. Okay, you can see immediately that there is a much lighter, thinner gap between the passes, and that should equate to, when we simulate it, a much finer finish on the vehicle. Now, as I simulate this, one of the things you may notice is the fact that there is a very small green bar along the bottom. If I had done these codes wrong, what would happen is, and say the bit on the cutter clashed with our spigots, what would happen would be that the machine would throw a red line through this, and if this occurs, you need to go and seek out a teacher to help you fix it. Okay, that's the thing you've got to have to do. You can watch these all the way through. I suggest you do, because it means that you can simulate whether or not your car will be manufactured properly. It needs to keep going through, obviously, the whole way. I'll speed up the process and hopefully it will re-render there, not taking too long. And you'll notice that most of the cars have been manufactured out. The reason we obviously have our spigot at the front there is so that when we manufacture our vehicle, we then have it connected to the rest of the material. Now, the material is held in the end here, and if you completely cut through all the way down there and you didn't have that little balsa spigot that I designed before, what you find is your car would just drop down. So, pretty important. And that is the simplest code you can pretty much make that will give you a really nice finish. Also has a very low amount of wear on the CNC. So I am now going to go to close that. I'm going to save this, and effectively that's the first component of our CNC code complete. Well done.